Today we're going to do more problems in those areas and move on to new concept. But before we move on, I would still want to emphasize something before you guys forget, which is your force member. There are two rules. Rule 1. If you have a structure, I don't care what here inside. If you have something stick out, something like this, and there is no external force applied to this thing, you might have something like this. So, can you identify all the zero force members over here? If there is no force over here and they are connected with each other with a joint, those two members are zero force member because there are two important rules you need to fulfill. Force in x direction and y directions are both zero, right? So if you have those things over here, you're going to find if you put the coordinate along the member, one of the equation is going to have two terms, and the other one is only have one terms, which means in order to fulfill those two equations, both of them must equals to zero. So you need to mark those two are zero force members. And when you remove those two, 3 and 4 becomes a structure sticking out from somewhere, and they don't have any external force applied to it. So 3 and 4 are going to be zero force members as well. Okay, that's rule 1. Rule 2. If you have two bars connected as a straight line, and we don't have any external force applied to this thing, meanwhile, I have another member joined to this connection. So over here, what happened is this member over here must be zero force member. The reason is, again, if I'm using regular xy coordinate, over here, the force in member 1 and in member 2, they must be equal but opposite directions in order to make the horizontal force equals to 0. However, this one is going to join another force along here, but this is also the single force along y direction, which means this member must be zero force member. So when we are doing the this kind of problem, we only have two rules that we need to judge which one is zero force member. This is going to be in one of the problems in the exam. Okay. Then we talk about method of sections. Again, when we deal something like this, we always want to identify what are given and what we need to find, right? I would say this is optional. Step 2. Why? Because when I give you a structure, sometimes I'll give you the force applied to a single end. Sometimes I just say, okay, there is a load in the middle, and I don't give you any other information. So in that case, you need to have free body diagram or a whole structure. Then solve force at ports. So, in other words, when we are having these kind of things, when we have a structure and we have either it's bearing, it's a normal contact surface, it means that at those contact surfaces, they are external forces try to support the whole structure. So before we can move on, we need to solve all the external forces applied to a system, which means we need to solve for the forces applied to the supports. Does that make sense? But sometimes it's not necessary, because sometimes those supporting forces has been specified in the problem statement. So this step might not be necessary. But most of the cases, I would suggest you still do this. Just be safe. Okay. Then step 3, make a cut. What do I mean make a cut? So I'm going to show you later. So when I say make a cut, in the problem statement, it will tell you which one is the interested member. You need to identify the force existing in the specific member. So when you make the cut, you need to ensure you cut through the member specified in the problem statement. If you fail to do that, you have no idea what the force is applied or existing in the specific member. So in order to do that, we need to make a cut through the member specified. But keep in mind, we would like to make a cut through as little as few members as possible, because if you cut through like 5 members, what does that mean? If you cut through 5 members, it means that you will have 5 variables or 5 forces you need to solve for the cut, which I wouldn't say it's not possible, but it's certainly going to be very, very tedious. So if possible, try to make as few as you can. Then the next step, you need to do free-body diagram of sections. You might need to do that once, in most of cases, or most the problem you're going to solve in the exam, you only need to do the free-body diagram for once. But in some real cases, you might need to do a free-body diagram. For you make a cut, you need to do the free-body diagram for here and for here. Then you're going to solve for the unknowns. Once you get this done, equation of equilibrium. Three equations, because I'm not going to ask you to do 3-dimensional problem, so you only need to deal with 2 equations for forces. This one depends. If you only have 3 variables, then you use 1 moment equation. If you have multiple variables, let's say it's 4, then you need to have 2 moment equations, so you have enough equation to deal with all the unknowns. Okay. Then the next step. Solve for unknowns. Okay. So that is going to be the steps that we're going to deal with for using method of sections. Any question? Okay. I need to tell you this kind of problem is for sure going to be in the exam. So be sure you understand the process and know how to solve that. Okay, so this is the configuration of the structure of the truss that given in this example. Obviously, it's a lot of members, and if you try to solve the problem using method of joints, it's going to take you a few pages before you get everything done. So for this kind of problem, if we only interested in a specific member, then we're probably not going to do something like that. But we want to, in this specific problem, the member we try to find, the force of the member we try to find is the force supported by DJ, this member over here. So we would like to use method of section to figure out how much force and spin provided in this member. So we need to identify what are given and what we need to find. We are given two loads, two forces, and one truss. We want to find F DJ. So when we start to do that, obviously we don't know the forces at the supporting points over here. So based on what we have over here, we need to do the free body diagram for the first part. So we're going to do that. When we do the free body diagram for the whole system, all the members within the structure, we just totally ignore them. So when we do that, I have two forces, 6 kip over here, and 6 kip over here. And at point A, this is bearing, so I have AX and AY over here, and I would like to use both of them to the positive direction. So if I get the negative sign, I know what's going on. And at point G, I only have one support. So with the configuration shown here, it is kind of straightforward. The total force in x direction equals to 0, which means AX equals to 0. I have two 6 point downward, so I have negative 6 for both of them. And I have AY and GY over here. So this equals to 0. Then I would like to use the moment equation at A. It is going to give me GY multiplied by 1, 2, 3, 4, 5, 6, 60 feet. And since I'm using this one as my reference point, it means that this is going to be counterclockwise, so it's going to be positive. But the other two 6 kips are going to give me negative moment because they are clockwise. So I have 6 multiplied by 10. The distance over here is 10. And the other one is going to be 1, 2, 3, 4, 5, 50. So with this equation, we can solve GY actually equals to 6 kips. Okay, because this is 60, this is 300, so this is 360 divided by 60 is going to be 6. Okay, so we know this is 6. Clearly, AY is going to be 6 if you want to make this equation equals to 0. Okay, so we pretty much finished the second step over here. Now, we need to make a cut on the structure. Which member are we trying to find? DJ, right? So which cut we should make? Certainly you need to cut this one. Right? So what else you need to cut? Well, over here you actually have very little options you can do. You don't want to cut the same member twice because it will be a little bit difficult to solve and it's going to be very confusing. So you probably need to cut like this. Okay. But before we do that, I would like to identify the angle over here. I know this is 12 feet based on the given configuration, and over here this is 30. So say that over here is going to be 21.8 degree. Everybody know how to do that, right? It's going to be y over x is going to be a tangent value. So if you take our tangent of 12 divided by 30, you should be able to get the angle is 21.8 degree. Okay. So with that said, I will start to draw my free body diagram. For the section, I just cut out. Else, I'm assuming my forces are okay, so this is going to be the free body diagram I need to deal with. Obviously, how many unknowns we have? 4. So there are some things that we certainly won't be able to do. And the angle of FDI is something we don't really want to deal with, right? So what we're going to do is first, I would like to use Moe equation. So if I use Moe equation, I would like to use this unknown in this equation. If I can only just use one unknown, that will be great for the combination. Is this possible? We find any moment center in this structure that eliminate the most number of the unknowns.
D.
Yeah, we can use D. Why? Because all those three forces is going to be pointed to D, which means the moment R for FDJ, FDI, and FCD, they are equals to what? 0. Does that make sense? So if I use the moment at D, I have two forces that we pretty sure their moment arm are just the distance between D and the applied force, which are given. So we have 6 multiplied by 30. In this case, it is negative. And we have 6 kip, which is this one, but this time it's positive. The distance is 20. Now, we would need to find out the moment created by fjk over here, because as I said, this one, and this one, they are all zeros. Okay, so we need to find out the moment over here. Of course, you can say you want to do the moment over here, but I can tell you it's going to be a little. It's doable, but I would suggest you just break this one into x direction and y directions. It will make your calculation easier. So if you do x direction, the theta over here is what? 21.8 degrees. So I have fjk cosine 21.8 degrees. The moment arm over here becomes 12. In this case, I'm going to give negative because I'm assuming the force is pointing to this direction. So if I do this equation, it must equals to 0. So we can just solve for fjk and figuring out how much force this force is going to be. Does that make sense? How many unknowns we have in this equation? Just one. So it's pretty straightforward. You just move this to the other side and use the other two terms and calculate for the fjk, the unknown value. So if you do that, you're going to find fjk actually equals to negative 5.79. What does this tell me? I have a negative sign in front of it. The direction of my assumption is what? Opposite. So it should be a force pushed to this direction instead of a void out. Does that make sense to everybody? Now, I have done this, but clearly, if I want to deal with all the other three equations, the other three forces, how many variables, how many equations I need to have in order to get FDJ, FDI, and FCD? 3, right? Do you really want to do that? No. One other reason I don't want to do that is because I don't really know the angle over here. Right? So that is something I really don't want to deal with. So if you don't really want to deal with what is the property you really need to solve for the red 3 unknowns, which one is required? FDJ, FDI, and FCD. What is the problem statement? Tell you which one you should solve. FDJ, right? So if I need to solve for FDJ, I don't care how much force this one and this one are. So if you don't care how they are, don't bother to solve them. Is there any other way that we can solve for this force which only include this unknown? We do. In this case, I combine method of join. Which join you think I'm going to use over here? I know fjk. Which other forces I want to use? I can deal with 2 unknowns. And if I use J as my joint, then there are 2 unknowns I need to solve. One is here and one is here. But how many equations I have? 2. So is that possible for me to get FDJ? Yes, right? So we are going to do joint J. And based on the configuration, I know I have FDJ over here. I have my force based on the calculation over here. This is going to be 5.39. I don't know anything about this force. Let's assume this one is Fij. How many unknowns I have in this three-part diagram? 2. How many equations we can use for this specific joint? 2. So we should be able to come up with the correct answers, right? So let's do that. So Fx, we know this one is what? 21.8 degree. This one is 21.8 degree as well because they are symmetric. So when we don't know that, it's going to be a negative 5.39 cosine 21.83 plus Fij. Because one equation, one unknown. You should be able to get this. How about the second one? It's going to be negative Fij plus 5.89 in cosine So this one is solved through this equation. This equation becomes only single unknown. So if you do the calculation, you're going to find Fdj equals to 4. Does that make sense to everybody? The last step we need to do over here is to determine whether this is under tension or this is under compression. So we know this is going to be down at this joint. What kind of force I have applied on this specific member? Because this is Newton's third law. So based on this configuration, tension. Does that make sense to everybody? Is that straightforward? Everybody understand what I'm doing? If you want to start from the method of joints and figuring out all the forces of every member, it can be extremely tedious. Though I wouldn't say the process is difficult, but based on the configuration over here, you will need to identify several things. One, the angle here, which is something we do, and the angle over here, and the angle over here, which is essentially going to give you a lot of trouble, right? And after everything is done, you need to solve for the combination of two equations for 1, 2, 3, 4, 5, 6, 7, 6 at this 6 times before you can reach this point, because you need to start from some point you know already, which should be starting from A or this point. So I wouldn't suggest you seeing these kind of things start right from method of joints. Specify which member you are interested in, cut that. If you need some information, start from the beginning, treat the system as a whole. Get the forces of the supports, which are also your external forces. Once you get that down, make a cut, just like a step over here. Make a cut. Make sure you cut through the member you are interested. So when you do that, you eliminate as many unknowns as possible. Then you might not need to use method of joints. Sometimes you might just use 3 equations, then you can solve for that. If that's the case, do that, because the more method you apply, the more mistake you're going to make. That's the rule of thumb, right? So if you only have 3 unknowns in your problem, just use moment and 2 other force equations. You should be able to get all the information with the force which the member you are interested. If it's not the case, then you consider to use method of joints. Combine both methods together to eliminate the equations you need to solve. To eliminate the unknowns in your system, then you should be able to find everything straightforward. Okay, I wouldn't say this kind of things is really so easy to visualize what you need to do in particular. Most of you guys might not really know you should use method of joint at this moment, but try to understand the process I'm working on over here. Rule of thumb: if you are using, if you have only 3 unknowns, just do method of joint sections, because that's more straightforward and you are going to make this mistake. If you find out, well, I have more unknowns than my equations, then you consider use method of joints, because method of joints is going to eliminate some of redundant forces, which FCD and FDI in this case, they are not necessary, right? So for everything I solve over here, do I know FCD? No. Do I know FDI? No. I only know this force and this force, and this is something necessary before we move on. So that is how we approach this kind of problem. Any question? Is that straightforward? Everybody understand what I'm talking about? If I give you something similar in the test, you know how to solve that? Or the answer is we'll see. Then the example that I would like to talk about is actually a quiz you guys had yesterday. It's actually similar approach. The only difference is that I kind of specify what you need to do step by step in the problem statement. In the notes. The configuration is like this. So here is 2 meter, here's 2 meter, here's 2 meter. So I would like to know the force of CE, this member, of the loaded truss. Okay. So before we start, let's figure out the geometry. Configuration over here. This is 2 meter, this is 2 meters, so what is the angle over here? 45 degrees. For some reason, a lot of you guys see 30 degrees over here, then you ignore the geometry configuration in your problem and assume this one is 30 degrees, or assume this one is 45 degrees. Don't do that, okay? You need to determine the angles based on the geometry relationship. That's also a problem I see a lot of you guys. If you see a bar doing something, in its orientation say it's 30 degrees, and you put another, for instance, if I'm telling you this is 30 degrees and 4, cable over here. I don't know why is that, but a lot of you guys is going to assume this angle is 30 degrees. That's not the case. It's not always the case. Okay, only when this line and this line are parallel, then they are 30 degrees. And the other thing is, last time, I think this is in the first exam. This is 30 degrees, and this is something I didn't given you, and for sure this is 60 degrees. And I'm asking you guys, there are two combinations of forces over here. I ask you to get me the resultant. And for some reason, a lot of you guys just assume this is going to be 30 degrees, which is not correct. Okay, so when you are doing those kind of things, just be careful. They are not, if I didn't specify the angle, then it's not the angle you see in the configuration. Don't just assume, do the calculation, okay? Anyway, I'm given a truss and a 3 kilonewton force applied to the truss. I would need to find FCE. So let's start. I would still like to start from the free body diagram for the whole system, which is going to be something like this. Over here I have dy, dx. Over here I have ay. And meanwhile, I have another 3 kilonewton apply over here. So that's my free body diagram for the whole thing. I believe most of you guys get this part. Not everybody, but most of you. Okay, so when I solve for this problem, those two equations are the first two equations you should think about. So I have 3 kilonewton. Is that cosine or sine along the x direction? In this case, in that direction, it should be sine, right? Some of you guys use cosine, so make sure you use the correct angle and correct sine cosine value, okay? And since this force is pointing to your left hand side, so it must be a negative sign in front of it. And the other force you need to deal with is dx. This equals to 0. For y, I have ay plus dy minus 3 cosine 30 degrees equals to 0. So I have two equations of 3 unknowns, which means I wouldn't be able to get all the numbers based on those 2 equations. But over here, dx is straightforward from the combination of x direction forces. That is going to be 1.5 kilonewton. And for the force over here, I would like to use A or use D, it doesn't really matter. I can use the moment and A, which is this one. So in this case, this force over here is going to create moment in 2 directions when you decouple this force into x direction and y direction. So we're going to have 3 cosine 60 degrees, which is the vertical force, multiplied by 2 meters. But since I'm using A as my reference point, so this is going to be negative. And we also have 3 sine 30 degrees, which is this one, but in this case it's going to be positive. The moment arm is going to be 2.
Like there's on the there's on 30.
Oh yeah. Okay. The other force we have is dy. The moment arm is 4 meters, which equals to 0. So that is straightforward. You're going to get your dy equals to 0.549 kilonewton, or your ay is going to give you 2.05. Now, you want to find out the force F of here. So you make a cut. So if you want to use method of joint, method of sections, you can just cut over here. So how many forces are we talking about here? 1, 2, and 3. So you can start by solving that. So if you do that,
The first part of the problem said to find the member from CD, not
yeah,
CD.
yeah, I know, but this is in your notes.
Okay.
Yeah. Well, let's do a CD first. If you want to do CD, you can just, the easiest way is just make a cut over here. Or you cut over here, doesn't matter. Okay? The point is, you will need to cut through the one you are interested in. What did I really ask? CD? Okay, so I make a cut through here. Whatever you know where I cut. So this is FCE. This is FE. Over here, I have 1.5, and my dy is okay. So, how many unknowns we have here? 2 unknowns. We don't really need to use moment equation. We can solve that. It's just similar to method of joints, right? But if I make cut over here, the only 2 external forces that I need to worry about is this. So this is going to be 1.5 kilonewtons. This one plus FDE. The angle over here is 45 degrees, as we determined in the very beginning. So it's going to be FCD cosine 45 degrees, obviously equals to 0. For FY, it's going to be 0.549 kilonewton. minus FCD sine 45 degree equals to 0. So in this case, we don't really care about the FCD. That's something you guys do in your quiz, right? So if you do that, what do I have over here? That's the second part of your quiz. Does that make sense to everybody so far? Yeah. What am I interested? I'm interested in this thing. So it doesn't matter how I cut it. It's going to be a little bit tedious. And if you try to cut over here, it's going to have 3 unknowns. But at this moment, we already know FCD already. So you can say I want to use joint C. That's something I asked you guys to do, right? So when you do joint C, you're going to have 3 kilonewton over here, and you have your FCD you also have your horizontal part from member BC. You also have another force from CE. This is something we are interested in. So, how many unknowns do I have here? 2. How many equations I need to deal with? 2. So, you just, because FBC is horizontal, FC is vertical, so what you really need to do is deal with only single equation, which is y. So I'll write down the equation in y direction. That is going to be 3 cosine 30 degree negative plus 0.776 cosine 45 degree upwards plus FCE equals to what? 0. One unknown, one equation, you're going to get FCE equals to 2.05 kilonewton. So, those 2 examples I just showing you are the combination of 2 methods, method of joints and method of sections. So when you are dealing with those kind of things, you need to combine them together so you know what to do. Does that make sense to everybody? Is that clear? Everybody know what I'm doing? Any questions seriously? Because this is going to be in the exam. Yes?
When you drew your free body diagram of the section over there, how did you know that FDE would be to the right?
I don't.
Okay.
I don't. I just assume that's positive. I don't. Good question. I don't. You can say this is going to this direction because based on the configuration over here, it should be this direction, right? If you think it's that way, do that.
So the same for FCD, you can make it go.
Yeah, it doesn't really matter because the only thing you might need to be careful is when you try to solve this one, you need to ensure you put a number over here, the direction is something. Correct. If you say this is negative, it's going to be that direction. Somewhat it's going to be confusing. No, most of the time we like to use positive values when you draw the free body diagram with the arrow in correct direction. That is something I would like to do. But it's up to you. There is no rule for those kind of things. As long as you won't confuse yourself while you're solving these kind of things, you'll be fine. That's text break. 5 minutes. Frames. The machines. I'm not going to go through machines because I don't think we have enough time. But when we are doing frames, there is one important thing you need to know. When we are using frames, we're going to have multi-force member. Okay, so when we have multi-force member, it means that we would need to do the free body diagram a little bit different. For instance, this is in your notes. When you have multi-force member, the third force in your system, you won't be able to. What is two-force member? Let me start like that. What is a two-force member? Two-force member, which means you have only forces applied to a single member on a specific component, right? And when it's two-force member, it's not moving, it's not rotating. So the two forces, for instance, this one, the two forces located here and here is going to have the same orientation, but opposite direction. You guys still remember that? That's the definition. However, if we have three-force member over here, we also know the rule. The rule is all the intersection going to be going to the intersect at the same point. That's the three-force member. However, if we have more of that, you cannot say that anymore. So most likely, when you have this kind of problem, though we know the direction of this one, we know the direction of this one, we don't really want to use geometry method to solve for that unless that's specified in the test. Okay. So when you have the force applied over here, you would like to decouple this into x direction and y direction, even in your free body diagram. That will make your calculation a whole lot easier. So with that said, over here, how many components we have? 3. So we need to do free body diagram. How many free body diagram we need to deal with to find out the forces of all the connections? 4. Why is 4? The first one is the whole structure. So in this case, if I don't have any external forces applied to it, I have dy, dx, and over here, I have, let's say, a1, okay? Does that make sense? Of course, all of the forces over here are equals to 0. Only when we have external forces, they are not going to be 0. But other than that, in order to find the joint, the force in individual joints, we also need to have free body diagram for individual components. Obviously, at point D, there is the same. At point A, it's going to be like this. What are others? First, identify two force member. Do we have any two force member here? Which one? BE. So we know BE. So over here, I know it's going to be BE. Apply at both ends. Is there any other place we can use FBE? Here and here, right? So I assume this is going to be something like this. At the other side, it must be opposite direction. same magnitude, opposite direction. How about this one? Is AC or CD two force member? No. If they are not two force members, we cannot assume the force over here is this direction and this direction, because they're simply not going to apply with each other. Right? If you say the force over here is this direction, this force is going to be in this direction, what are you assuming? They are zero force member, because along x direction it must be 0, which is not possible. Because if you assume this one is direction, you won't be able to compensate for the force in this direction. So if this force is in this direction, you won't be able to have projection of this direction, which means your assumption is not correct if you assume that is this direction and this direction. Make sense? So what do? We need to decouple everything into Cx and Cy over here. How about the other side? Newton's third law tells us in order to keep everything 0, you must have opposite direction, same magnitude. So this is right hand side upward, the others must be left hand side downward. So that is going to complete our free body diagram. The rest is similar to what you did. You just do the free body diagram and do the 3 equations. For individual components, then you're done. Does that make sense?
Why do we have to decouple the top body?
Those two?
Yeah.
Cx, Cy. As I said, this is not 2 force member. It's 3 force member. So the force at this point is obviously not like this. This is not going to be like this. If you are assuming that, then it must be 0 force member, because if you decouple that into this direction, and you need to project this along this direction, one of them must equals to 0. So we don't do that. So the easiest way we deal with that is you decouple that into x direction and y direction. And when you do that x direction, y direction, because they are connected with each other, right? So based on Newton's third law, it must be opposite direction, but same magnitude. So if you say you assume this is going to be this one and this one, then the forces at this point must be this one, this one. Okay? Is that hopefully I can finish 2 examples. Okay, so I have a structure like this, and I assume the weight of the members are 0, all of them, and find loads acting on the frame as support A and C. So in this configuration, do we have any 0 force member? Not really, because over here I have force over here, here, and here. Over here I have force over here, here, and I have a moment in between. So both of them are not 0 force member. Do we have, both of them are not 2 force members. So when we draw our free body diagram, one force, one member, y, reactions at A, C. Okay, so if we draw a free body diagram for individual ones, of course, if you want to deal with this specific problem, you can just do the whole system and you should be able to solve for all the unknowns. But over here, I'm going to decouple everything into two parts and deal with the force equations individually and show you how to approach that. That's an example. So I have two members here, bar AB and bar BC. So if I draw the free body diagram over here, I have 150 pounds located over here. So what kind of forces I have at A and B? So point A, what do we have? Is a bearing. So what kind of supporting we have? AX and AY. Is this two-force member? Obviously not. So if this is a three-force member or multi-force body, what do you want to put over here? Single force or two force? Two force. Normally we treat that as just X and Y. So in this case, I assume it's going to be dx dy. There is no reason because I want to assume both of them to be positive. That's all. Okay? So since I say both of the forces are positive direction over here, what do I do at this position on the other member? Opposite. Okay, same for C. It's going to be Cx, Cy. But other than that, I also have one other moment in between. So that is going to be my free body diagram for AB and BC. So far, any question? So let's start from member AB. That is still straightforward. Fx equals to 0, Fy equals to 0. That is going to be Ax plus Bx equals to 0. So it yields Ax equals to negative Bx based on this equation. So you can replace Bx with Ax or Ax with Bx. It's up to you. For Y, it's going to be Ay plus By minus 150 equals to 0. So it yields Ay plus By equals to 150 pounds. Then the next thing I would like to do is one more equation. Let's do that at A. So I have 150 multiplied by 3, which is negative, plus By multiplied by 6 equals to 0, which makes By equals to 75 pounds upwards. When you get this equation, when you get this result, plug this back into the Y equation, you'll also get a Y equals to 75 pounds as well. Okay, so over here, A, B, So over here, you will be able to get by, ay, but can you get an ax and bx? Not really. We only know that the relationship. We only know that ax equals to negative bx. That's all. But we don't really know the numerical numbers. So I'll stop here and move on to the other member to see if the other member can give me better idea. So if I do member BC, Bx is going to be negative direction, Cs is going to be positive direction, and they must equals to 0 when we combine them together. And Fy is going to be negative By plus Cy equals to 0. Do we know By? We do, from the first part. It's 75 counts. So clearly, Cy is going to be 75 counts as well. Right? But we still don't know Bx and Cx. So what we're going to do is to get the moment and C. So when we do that, we know this is 60 degree. We know that the length of this member is 4 feet. So when we do that, it's going to be that is this one negative in front of it because it's clockwise. No, it's positive. It's positive, I'm sorry. It should be positive. And we have two forces, Bx and By, that are going to create moment, right? So if we do that for Bx, it is going to be 4 feet cosine sine 60 degree and this is going to give me positive value, right? And the other one is going to give me By multiplied by 4 cosine 60 degree. And in this case, I'm going to have negative value. Any questions so far? Hold on, I make a mistake. Yeah. So this is positive as well. Do we know By? We do know By from here, right? From here. So this is 75. So when we do that, you're going to find down Ex equals to negative 86.6 pounds in this case, which means the direction is not correct. In this case, I mean at this joint. So we can conclude Cx equals to 86.6 pounds, and this equals to As as well. Okay, so that is how we deal with the force. The multiple members. guess it's about time. Any questions? Is that clear? Everybody understand what I'm talking about? So we're going to talk about one more problem tomorrow.